NASA's Kepler Space Telescope and the hunt for new worlds. When NASA's Kepler Space Telescope ventured into the depths of space beyond Earth's atmosphere, it reached a stable orbit around the Sun, approximately 94 million miles away from Earth. There, it fixed its gaze on a specific region of the universe, namely the constellations of Cygnus, Lyra, and Draco. When its cover finally opened, humanity witnessed a view of the night sky like never before. The 42 highly sensitive light sensors installed on Kepler began monitoring the light of 150,000 stars simultaneously to search for Earth-like planets. Planets in deep space, exoplanets, do not shine on their own, and they are so small compared to their brilliantly bright host stars that taking a direct photograph of them is nearly impossible. To solve this problem, astronomers developed the transit method. Example: imagine a lighthouse is shining brightly, and a moth passes in front of it. Even though the light might look exactly the same to your eyes, the presence of the moth actually causes a slight dip in the intensity of the light. Kepler uses this exact method. When a planet passes in front of its star, it blocks a fraction of the star's light, causing the star to temporarily dim. From the amount and timing of this reduction in light, scientists estimate the planet's size and its orbit. This is how we discovered rocky planets like Kepler 36b, which weighs 4 times as much as Earth and possesses its own atmosphere. We call them super-Earths. The Sagittarius stream and galactic collision. Where did we come from? To find the answer to this question, scientists are studying a unique group of stars known as the Sagittarius stream. This is a massive trail of stars stretched across the sky due to the gravitational pull of our Milky Way galaxy, originating from nearly 100,000 light-years away. Data from the European Space Agency's Gaia mission revealed that when a small dwarf galaxy named the Sagittarius dwarf collided with our Milky Way, its remnants formed these beautiful cosmic streams. Interestingly, this collision occurred just before the birth of our solar system. As a result of this impact, fresh and cold hydrogen gas entered the Milky Way, serving as the fundamental fuel to birth new stars. Hydrogen is the most common element in the universe, which we can observe and detect using radio telescopes. 4. Black holes where the laws of the universe collide. Black holes are the ultimate arenas where two of the greatest theories in the universe clash. Gravity, which controls the universe on a massive scale. Quantum mechanics, which governs the world of ultra-small particles, atoms. When we try to combine the mathematics of both these theories, they do not align and instead conflict with each other. At the dead center of our galaxy lies a supermassive black hole named Sagittarius A*, which possesses a mass equivalent to 4 million suns. If you were to travel toward a black hole, you would eventually cross the event horizon, the absolute point of no return. There would be no physical barrier or visible line in space. You would cross it quite smoothly. However, beyond this boundary, not even light can escape. Past this point, the universe becomes severely warped in both space and time. Spaghettification. The intense gravitational pull of the black hole will pull much harder on your feet than on your head. This extreme tidal force stretches you out into a long strand, eventually down to the width of a single atom. Large rocks are ground into sand, and sand breaks apart into individual atoms. Singularity. The absolute heart of the black hole, where all matter is so immensely compressed that it seemingly becomes nothing, yet still exists as everything. This is where all journeys in the universe come to an end. How do black holes form? When hot blue stars, which are 20 to 30 times more massive than our sun, completely burn through their nuclear fuel, the outward pressure generated by their radiation ceases. The star begins to collapse inward under the crushing weight of its own gravity. The matter condenses to such an extreme degree that the star itself completely vanishes, leaving behind a profound bottomless pit in the fabric of space. A black hole. This is like a waterfall in the fabric of the universe. If you remain at a distance, you are perfectly safe. But once you are caught in its downward current, escape becomes impossible. The stellar age and the cosmic timeline. We are currently living in an exceptionally fortunate era of the cosmos known as the stellar age. When we look at the grand timeline of the universe, it unfolds like this. 13.8 billion years ago, The Big Bang occurs and the universe comes into existence. In its earliest state, it is incredibly hot and dense, making the entire cosmos feel like the inside of a star. 400 million years later, the very first stars are born. 9 billion years later, our sun is formed. The present era, 13.8 billion years have passed since the dawn of creation. Our sun will begin to die in about 5 billion years, though smaller, low-mass stars can continue to burn for trillions of years. However, this glorious age of stars will not last forever. A time will inevitably come when the universe runs out of the cold gas required to birth new stars, and the old ones will gradually dim and burn out. Compared to the infinite timeline of the universe, this illuminated era of stars is a mere blink of an eye. The true, everlasting lifespan of the cosmos belongs to the absolute darkness that will follow. Rogue planets and the dance of binary stars. Are we truly alone in the universe? When we broadcast messages into deep space, we are met with nothing but a haunting silence. But the universe can also be incredibly hostile. In 2020, scientists discovered an Earth-sized planet drifting through the galaxy entirely alone, without a parent star. Most solar systems in the universe are actually binary star systems, where two suns orbit one another in a cosmic dance. If a planet orbits within such a system, it would cast two distinct shadows, and its inhabitants would witness two sunsets. However, when more than two celestial bodies join this complex gravitational dance, the system easily descends into chaos. Due to the violent gravitational tug-of-war between the stars, a planet's orbit can be destabilized, violently casting it out of its home system to wander the depths of space forever as a rogue planet. 7. Touching the Sun, the Parker Solar Probe. To truly unlock these deep cosmic secrets, we must first understand our closest star. The Sun. NASA's Parker Solar Probe is one such daring mission, launched into space aboard the powerful Delta IV Heavy rocket. During its 7-year mission, this probe will complete 24 orbits around the Sun, diving deeper into its outer atmosphere, the corona, than any spacecraft has ever dared. It stands as the fastest human-made object in history. By braving this extreme heat, it will reveal the mechanics of how stars form, how they release energy, and what the previous generations of stars were like. Ultimately, this will allow us to fully comprehend the origin story of our universe and accurately map the ancient light of the Big Bang, the cosmic microwave background, much like the groundbreaking work done by the European Space Agency's Planck telescope. From the watery clouds discovered by James Webb to the burning secrets of the Sun touched by the Parker probe, one thing is absolutely clear: the universe is not just stranger than we imagine, it is stranger than we can imagine. As we stand on this tiny rocky planet, looking out into an ocean of trillions of rogue worlds and twisting black holes, we realize that our journey of discovery has only just begun. Which cosmic mystery fascinated you the most? Let us know in the comments below. If you enjoyed this journey through the cosmos, make sure to hit that like button, share it with your fellow space explorers, and subscribe USA Realty channel for more deep space adventures. Until next time, keep looking up.